right, here we go. So walking through how to change the mathematical design into a physical design with made-up numbers. So my made-up spring constant for my whole bungee cord is going to be 30. And so I designed this. I had a fixed cord length of 1.7 meters. This was newtons per meter. And an elastic cord length of, anybody? 8 meters? Nah, that's too short. 0.8 meters. So 80 centimeters. That's a little bit better. All right. So that's what I found from my mathematical design, and all the other stuff would be filled in from the spreadsheet. When I tested my elastics, and when I went on iSense, and I looked back at the number I had in number 3, I was pretty happy with it, but I went back and checked iSense. I came up, guys, just for a couple minutes. I came up with an answer. I wanted to use 45.2 newtons per meter. All right, so I got that from my sheet or from iSense, one of those two places. And now this is where I start to design how many rubber bands do I have to use in each strand, and how many strands do I need so that I can meet the criteria over here in yellow. So the length of the elastic series strand that I need, I get that right from the yellow. Elastic cord length, for me, 0.8 meters. So now I think, how many elastics do I have to put in series to have an elastic strand that's 80 centimeters or 0.8 meters? Well, I found that each elastic was 9 centimeters long. All right, in my testing, I looked back earlier. So I'm going to take and divide the 0.8 meters by 0.09, or 9 centimeters, and it comes up to 8.88888 repeating. Well, I have to use full rubber bands. So right away, I got to make a decision. Do I use 8 or do I use 9? And that's a decision you make as a team. So Nate, which should I use, 8 or 9?
I guess 8.
Okay. What do the rest of the team think? 8? Okay. Personally, I probably, if I was on the team alone, because it's 8.8888, I probably would have rounded up to 9. But that's fine. It's a choice you make. But don't be afraid of going either way. So final length of strand. Now I say, well, I only have 8 bands in there. They're only 9 centimeters each. So rather than being 0.8 meters long, my strand is really 0.72 meters long. And then now this is where I start using the information I gained in 2 and in 3 also. K for each series strand. So if I take 8 rubber bands and they each have a K of 45.2, how much do those 8 have when they're put in series? And the answer, of course, when you put them in series, it decreases the overall. And so 8 rubber bands of 45.2 newton meters in series means each strand has a K of 5.65 newton meters. And I used our good old 1 over K1 plus 1 over K2 plus 1 over K series that you guys did in earlier times. So each strand has a K of 5.65. How many strands in parallel do I need to come up to my 30? So now I'm using K1 plus K2 plus equals K in parallel that you got earlier. So 30, I'm dividing 30 by my 5.65. It tells me 5.3 strands. I can't have 0.3 of a strand. So again, I'm going to say, I'm going to use 5 strands. I'm rounding again. And so if I have 5 strands that each have 5.65, as their K. I actually have my elastic cord is going to be 28.3 Newton meters rather than my 30. And so I'm going to build and this is what I would describe down here, I'm going to build 5 strands of 8 elastics each. And that will be the elastic part of my bungee. That would take me 40 elastics, and I need 1.7 meters of fixed cord. Now, I might want to go back because these numbers are a little different, 0.72 and 28.3. I might want to go back and put those in my spreadsheet and make sure that like the bear is going to be where I am, or maybe I adjust it a little bit. But that's how I do the design portion of going from mathematical to physical.